Hello, Urbit fanatics, and welcome to a special episode of 0K, the podcast where we talk to some of the people building Urbit, the decentralized operating system for the next 500 years. Today, our episode is a special conversation between Ted, aka rovnys-ricfer, aka the CTO of the Urbit Foundation, and Illia from the Near protocol. So, Urbit and Near have partnered to build a client for Near's blockchain operating system over the course of this summer. So we've entered into a kind of partnership with these guys, but this is kind of the first that I've heard an in-depth discussion of Near. So it's been a great listen here. So in this conversation, they talk about the origin story of Near, kind of where they came from. They also talk about what unites the two projects, which is this emphasis on usability for both the developer and the user. So this is something that in the decentralized space, let's say, it's pretty clunky. So I think both Urbit and Near are kind of targeting this. And so you'll hear a little bit more about that. And then you'll also hear kind of about what the future could possibly hold between these two. So it's a great listen. I think you'll enjoy it.
All right. Well, Illia.
Hello. Thanks for inviting me here.
Thank you very much for joining us. So I thought I'd start by asking you how you got into Near, how you started it. Because you were one of the authors on the original Transformers paper, which led to ChatGPT and this whole AI revolution that we're experiencing now. So how did you go from that to crypto?
So pretty much I was working at Google Research. I was working across natural language understanding, but kind of deeply rooted in me, I always wanted to teach machines to program. And I saw an opportunity to go start a company to do that. So we started Near AI first. And Near AI was really teaching machines to code, right? So in a way, what GitHub Copilot is right now, except we did not have Microsoft money or GitHub.
Many such cases.
And so we were needed to be smart, right? And so what we ended up doing is trying to find places where we can get, especially students, to do data labeling for us, so we can get a more clean data set to train models. And kind of the people who would do that, and proficient developers that are students that are looking for extra income, usually are from developing countries like China, Russia at the time, Ukraine, Poland, etc. And with all of these countries, there's actually a money transmission problem between US, where our company was based. The students also sometimes don't have a bank account. PayPal doesn't work in some countries. TransferWise doesn't work in other countries.
Yeah, my dad has this problem. My dad teaches remotely in China quite a bit. But he lives in the US, and so these universities in China try to pay him, and they have a lot of trouble. It's all legitimate, it just doesn't work very well.
And so we ended up starting looking at blockchain just to solve our own problem. It's like, how do we pay people and make it automated, program it, make it really effective and efficient from our side, where we're like 3 people startup, right? And so starting looking at Bitcoin and Ethereum, your usual journey in Web3.
Yeah, what year was this?
This was 2018. So okay. Already everything crashed, hype kind of started to die down, which is a good time to come in. And so we were looking around, and we were paying 10 cents per task, 5 cents per task. And so, transaction fees, which were, even back then, were already 20, 30 cents, were not realistic for our use case. So we started looking around to other blockchains and other layer ones, didn't find anything that would be coming from a distributed systems background, from algorithms background, nothing that would fit what we thought makes sense.
Yeah.
And so, and we saw opportunity to build something that is truly scalable, but more importantly, actually usable for developers and users, and really kind of enables more of this business use cases, right? Not just kind of money transfer, but actually true business use cases on top.
Yeah, it's interesting. So we had a similar problem at Urbit. So the original Urbit public key infrastructure was not on chain. It was just, the idea was that you would use an escrow agent to sell an Urbit address, like selling a house. And that we just accepted that there would be Byzantine fault problems with this. Is sometimes people would double sell, it would just be a problem. But then it turned out we really needed to go on chain. like you really do want a blockchain for managing assets. So we went on Ethereum around 2018, thereabouts. And then not that long after getting onto Ethereum, the gas prices shot through the roof, and suddenly it cost $200 to join the Urbit network. So nobody got on the network for a year, and it was really tough for us. We ended up having to build a layer 2 to get the prices down to something that was manageable, and that took a lot of engineering effort. It has its own trade-offs. So we're okay now, more or less. But that was very rough for us. So I sympathize with what you're saying here.
Yeah, we should discuss that in more in depth. But
yeah. So okay, so you had this problem, and so how did you go about fixing it?
Yeah, so I mean, coming from distributed systems, like any distributed systems, right? You worked with any company that had any scale. The name of the game is parallelization, right? You run stuff in parallel, you have more machines, so as you add more users, as you add more load, you can add more machines and it scales, right?
Yeah.
Like that's how Google works, that's how Facebook works, that's how, WeChat, like name the app, they all work the same. And it was really interesting to see that in blockchain, that's not the reality, right? In blockchain, it was, you add more machines, it usually runs slow.
Right. Yeah, because you just have to inform those machines about the consensus.
All of that, yeah. And so our first kind of order of business is, okay, how do we parallelize things? And so from that perspective, you really need to figure out a new paradigm that actually goes from, well, if everything is in parallel, how do you actually build applications that way, right? Because, and we see this right now with like layer 2s and cross layer 2 communication. When things become kind of parallel and layer 2 to each other are parallel, layer 1s to each other are parallel, it's actually a different paradigm because it's asynchronous. You don't have atomic transactions anymore.
Right, because one layer 2 might update, the other one doesn't, and there's nothing, nothing forcing them to go together.
Exactly,
right?
yeah. Or it rolls back, or there's like latency, or it doesn't deliver the message, you need to rerun it, replay it.
Right.
And so we focused on, and at the same time for the user, this is a mess, right? Like if you need like, do I have fees and do I have an account in Optimism and Arbitrum? Do I need to send money between them? Like, do I need to bridge into it? It's like, so what we wanted to do is like, how do we achieve this parallelization, but hide this complexity from the user?
Yeah.
Right? And so again, if you think of it, you go to Netflix, it doesn't tell you like, hey, the server is, busy, pay more money. Or it doesn't tell you like, hey, you should select another server and watch another movie because this movie right now is really busy, right? No, it just like scales up, puts more servers in and processes it for you.
Yeah,
and like,
it just works.
Yeah, it just works. It's completely transparent. And so that's what we're aiming for. So we build a sharding design that can actually scale with the demand in the network, and kind of as more capacity is needed, more validators are required for the network. And at the same time, it's completely hidden from the user. Right, as a user, you still interact with one blockchain. You have account somewhere on one of the shards, but you don't need to know about it, and you interact with other applications. Now, there's a little bit of trade-off there, which means all the applications are communicating asynchronously with each other.
Yeah.
But we guarantee that the message will be delivered in the next block, and pretty much enable this like really kind of fast cross-chain communication where every contract and account is quote-unquote its own chain or shard. And so all of this is packaged, hidden. As a developer, you just send messages, which is actually very similar to normal web,
like
web
writing a web app.
development.
Yeah, everything's asynchronous in a web app too.
Exactly, yeah.
That's
so
fine.
like
People live
all
with
of the stack is asynchronous. So that's kind of the idea. And then we really focus on latency because we believe, if you want to achieve mass adoption and mass market, you need something that is truly kind of fits, Web 2 experiences. And so we focused a lot on 1 second block time, and we actually want to make it even quicker. And so to do that, we pipeline the consensus. So a lot of the consensus messaging, which, in things like Tendermint and things, like you actually wait for response from other nodes. Here you send messages always forward and kind of like pipeline things and allowing to have, 1 second block, next block, in normal circumstances already achieves consent, like pre-commit consensus, and then block after, you have BFT consensus in normal situation. So stuff like this allows to have like really quick finality.
So you said that what is the finality like?
So we like you can pretty much 2 second finality which if somebody will be slashed if this is double sign, and then like after 2 seconds, like the third second you have BFT finality. So like you would need to slash like 33% of stake to.
Okay, but so within 1 to 3 seconds, this thing is just done. Like I send you a payment, and we can just rest assured that the payment actually went through within a couple of seconds.
Exactly, yeah. And like
So
most people use 1 second optimistic pretty much confirmation. So like it's already in the block, and like we have very little rollbacks.
So in my mind, this seems like an enormous accomplishment.
I agree.
Yeah, I mean, because it just, when I think about how blockchains work and like what you would need to do technically to try to make that happen, like it's just not obvious to me that you.
No, and so we talked before about this, but yeah, like one of the things we've done, which not a lot of people know, we did a lot of work on the networking stack to make sure that the nodes are like constantly actually connecting and optimizing the networking graph. So in a way, each node actually has a partial kind of graph of the network available to them. It's actually cryptographically signed, and where possible, where there are validators, it's actually their validator key is also like cross-signs the node key, like the message passing key, to ensure that there's actually stake behind, so Sybil resistance stake behind the node. And so this allows to actually keep optimizing the network and creating direct routes between validators and between like RPC nodes to actually make this connectivity and like block throughput faster.
Yeah, I mean, you're making the peer-to-peer network actually much more peer-to-peer, right? And then it seems to me that like the Sybil resistance that you're talking about, right? Like if just having all these nodes talk to each other, and actually sign the messages to each other means that my guess is that then you can fight off denial of service attacks much better. And the system would be a lot more resilient if, say, like a state actor tried to attack the network and tried to take it down. Is that right? Or?
Exactly, yeah. I mean, the biggest thing for me, this is a huge tangent, but I think Kademlia tables are misused right now in peer-to-peer stacks of a lot of the blockchains, because Kademlia table is information retrieval, not a kind of this like management of the peer-to-peer connectivity.
And sorry, what was that about?
So Kademlia tables. So Kademlia tables is like a distributed hash table for networks, and so it's used, for example, for IPFS to retrieve content, right? Yeah. And that's a right usage. But then all the peer-to-peer libraries, like in Ethereum and others, use it as well to find peers.
Okay.
And so the challenge there is it's actually really easy to overwhelm. And like there's actually known papers on Ethereum, like from a couple of years ago, where they found that like with 2 computers, you can actually like create eclipse attacks on nodes, right?
That's not great.
And like they fixed it, like there's fixes around that, but like it's all kind of patches. It's not a conceptually fix. So, and conceptual fix, a lot of it is leveraging the ledger we have, which is the Sybil resistance around stake, Sybil resistance around accounts, all this information that we have to actually like leverage it on a networking stack as well. And so like almost nobody, like at least I've never seen anyone using the ledger level information at the networking stack. And so we've been.
Yeah, I haven't heard of that either. That's why when you described it to me the other day, I was like, that's interesting. Because it seems very unusual.
But it makes sense because like we have extra information to improve the both connectivity and kind of DDoS protection, Eclipse protection, and like why wouldn't we do it?
Well, so as I learn more about Near, I like it more and more. And a lot of what I keep encountering is that sort of at each layer of the system, it seems like the developers have been paying a lot of attention to how to make it sort of, technically very sound, very, resilient, and then also like usable by people for a lot of use cases and usable by developers. And this is an example. I mean, it's a pretty technical point, right? But I think it speaks to the general attitude of Near of like, even at this level of like, okay, how are the validator nodes talking to each other? It's like, well, what information do you have available that you can bring to bear to like make sure that it will resist a state attack by a state, something like that. I like that. I think it's very cool. That's what I want to say.
Yeah, I mean, it's a lot of work. There's a huge team of people, really smart people, pretty much trying to think. And so our background, right, is in programming competitions. And so in programming competitions, you have two sets of kind of 2 tasks. One is you try to solve really hard algorithmical problem. And then in some competitions, you actually try to break the other person's solution of this problem. And so that's kind of the mindset our team has in many ways, is how like somebody comes up with a solution and then everybody else is trying to break it.
That's cool.
And so that means it's a very rough environment, but
hostile work environment.
But the best solutions win. And it also allowed us, so we actually built 5 different consensus algorithms.
Really?
Yeah, so we built Hashgraph, we built Avalanche back before they actually had released anything.
Okay.
We built 3 of our own consensuses as well. And part of it was we built, Hashgraph is actually, it's good consensus, but it's very slow, it doesn't scale, and we really practically built it, experimented with it, saw it doesn't work, tried to optimize it. With some of the original Avalanche paper, there was some potential issues that you can do. We have actually source code and the blog.
Yeah, Avalanche, you can have issues with.
With liveness, pretty much. Yeah, you can keep it in method stable state. Yeah.
Yeah, I remember reading that paper and thinking it was cool, but wait, how do you address the liveness?
So they have ways to resolve it now, but
Okay.
so in original paper there was some of the kind of oversight on that, or some places to attack. We've also had found an issue with Solana before mainnet as well. They fixed it. So we've been also and we've had this whiteboard series where we interviewed other founders and the technical researchers on the protocols to really dive in and exactly how their algorithm is built, to really both for our understanding, for audience understanding, and also challenging them to find where exactly things are working or not working. So we've been trying to be kind of both positive to the ecosystem as well as be ourselves the experts in all of the stack to ensure A, we build the best stuff, but B, actually we continue advancing this field broadly speaking, right? And that's, to kind of come in on your side, I think it's exciting for you to also talk about, for near developers who will be watching, right, about Urbit, because I think that's a new exciting piece of stack in this decentralized Web3 ecosystem. And one thing I keep repeating actually, that Web3 is not just about blockchains, right? It's a lot also about on-edge compute and on-edge infrastructure, which we need to actually continue pushing this vision of self-ownership, of owning your assets and data. And I think Urbit is really kind of playing a big role in this, and that's why it's exciting to both be here in the partnership we're doing together. But yeah, would love for you to kind of, for the near developers and the people who are in the room to, give a download on that.
Sure. Yeah. I'm always happy to talk about Urbit. And I can do one of my many attempts to explain it. The basic idea of Urbit is that it's a new conception of computing where each person runs their own personal server. And then those personal servers communicate with each other in a peer-to-peer manner. And then why this is good, it's good for a number of reasons, but one of the big ones is that ideally a lot of these centralized services that we use right now can be replaced. And instead of having one server run by a big company, I run my server, you run your server, our servers communicate peer-to-peer, and we don't need a central point of failure, we don't need some company that needs to try to extract information from you. And one of the big things I think is that there's a fundamental conflict of interest that these companies have, right? Because they are trying to provide a service on one hand, but the only way that they can make enough money to actually run all their servers and keep the lights on is by extracting information for ads and also trying to get you as addicted to the platform as possible. You talk to most sort of normal people and they're not very happy with how much time they spend on their phones. Right? And if somebody brings up TikTok or Instagram, what do you think of? Do you think of somebody scrolling forever, right? And most people don't really want that, but that's kind of the internet we live in. It's not easy to get out of that and then still have good social functionality and good ability to organize bottom up and all these sorts of things. So with Urbit, the idea is you don't need any of those services to be done by a central server. I can run my little piece of that myself, you run your little piece of it yourself, and that's all we need. And so I also think that that's very complementary to blockchains. Right? And the big difference between Urbit and a blockchain, I get asked this a lot. Right? What's the difference between Urbit and a blockchain? And my general answer is that with a blockchain, all of the nodes participating in the blockchain, everybody stores the same data. So a blockchain is a way to get everyone to agree on the same data, the same state. And in contrast with Urbit, every Urbit node has a different set of data. And so I have my Urbit node is storing just my data, yours is storing just yours. And so they're all different. What do you think of that explanation?
Yeah, no, exactly. I think the kind of moving forward in the future, server or not, but our data should, continue living on the user side, right? And, you need some ways to, access it on your phone, on your laptop. You want to have secure backups of it. It needs to be encrypted and kind of in a way that only you are able to access it. And also compute should come to you, right? Instead of the services and data kind of living in the centralized place, the service comes to you and runs it on your data. And so that's very similar kind of the concept we are being introducing as blockchain operating system. Is really going kind of above just layer one and kind of realizing, in Web3, a lot of the kind of applications, although the kind of smart contracts are decentralized, but the rest of stack still lives in a centralized server, and actually all the logs, all the information, everything is still actually goes through a centralized stack, right? And so we're not starting to push kind of decentralization to the rest of stack, including through front ends and making them available, rendering them on the user side, allowing pretty much user to retrieve the pieces of front end and application that they need, bypassing any of the central kind of web server as well, and pretty much limiting what tracking you can have, limiting what kind of access these things have. And allowing pretty much user be in control of what they're accessing, but also be in control of if tomorrow developer decides to Uniswap tomorrow, Uniswap Labs, a company can tomorrow decide to put a huge ad banner on uniswap.com, and you cannot do anything with that.
Right.
Right.
Well, this problem already happened though, right? I mean, last year with Tornado Cash and the sanction, right?
Curve got hacked. Curve front end got hacked. It's a centralized server that got hacked. And so everybody who was going to Curve was actually accessing a malicious code running, and they wouldn't even know, right? And that just shows how not cryptographically secure the whole stack is.
Yeah, I mean, I'm really not happy that I have all these, I don't know, hundreds of logins to different services, just because I live on the internet. And each one of those services is storing my password. Some of them store my credit card information, some of them store my birth date and other personal information. There's nothing I can do to force them to have good security practices, and a lot of them don't. And then your passwords get compromised in a breach, just like everybody else's. I mean, how many hundreds of millions of people have had a password compromised from even a large site, Equifax, this credit card
my
processing.
one password always say this many websites were compromised.
Yeah, and it doesn't have to be this way, right? So I feel like most people don't know that with private public key cryptography, there's no need for a service to actually store my secret credentials. They could store my public key.
Yeah, and I can prove to them
use my private key to log in, and everything in crypto works this way, and except for Coinbase and other centralized services. But the sort of real decentralized systems, like the sort of cryptographically based systems like blockchains or Urbit, that's sort of laughed out of the room immediately as a way for this to work. But yet that's still where we are.
And by the way, devices now have cryptography embedded on the device. So we just rolled out recently FastAuth, which uses cryptography on device to generate the private public key. Private key is stored securely on the chip inside the device.
Okay.
Which you need, I don't even know how humanly possible to get it out of there without and so it's biometrically secure, so Face ID, fingerprint, or if you don't have that, PIN code. And doing that, you can start signing transactions now. And so we have a full flow where you Face ID, you log in, we have email recovery. If you want to, you can also remove it. But it allows you to now have this and don't need password. Your device is your kind of access. You can have multiple factors of authentication if you want to as well.
That's
so
really
you can
nice.
all do this while it also be fully cryptographic, right?
I mean, that sounds a lot nicer than sort of I log in with my MetaMask and then I go to I have a seed phrase, I log in with the MetaMask, it doesn't work, I refresh the cache,
Somebody mentioned there was some hackathon, Ethereum hackathon where some people built on Near, and when people compared, it felt like the Ethereum kind of examples were a MetaMask showcase, because every single action you need to go and click in MetaMask. And on Near, you authorize once, and then you have a session key inside the app, and you can just interact with the app. And so those are kind of things that to be clear, like Ethereum is figuring out, there's account abstraction, there's like paymasters, there's a bunch of stuff coming.
Yeah.
So we're all kind of converging to the same solutions. But generally speaking, that's what we're focusing on. Like, how do we create this experience to the end user such that it feels like it's Web 2, and ideally it's better than Web 2 because you don't have passwords, you don't have data stolen, you have your data accessible to any application, right? So the example would be, you have the social network, you go through one of the gateways, you have your social network there, you go to another gateway which is for work, and you have your social graph there as well because it's your social graph, not LinkedIn or Facebook social graph, right? So like that, and again, like Urbit here can be storing a lot of the private social graph parts that you can then plug into a specific.
That's really where Urbit shines, right there.
Yeah, and so I think like that is where we should be going, right? Like I think one of the questions like, what is the vision for this in 5, 10, 20 years? And the reality is like it's not going to be this like big companies providing services. It's going to be a lot of open source software that you can be like loading up. The open source software is cryptographically secured, it's audited, it's insured, cryptographically insured as well, such that if something happens, there's a way to get like recovery so that you don't have this hacks constantly happening that like financially devastating. At the same time, all the user data will be sitting on your device in kind of Urbit and in decentralized storage, allowing you to interact with your applications in any way you want, and having this like composability between all of them that we kind of seen glimpse of like back in like 2010 when Facebook like had an API.
Back when they had an API.
Yeah, and then like they shut it down and like threw a bunch of businesses out of
billions of dollars.
Yeah, and so that's kind of where we're going with all this, right? And that's what we're powering, and now we just need to make this last bits of experience working. And I think like we all kind of together right now converging on that state. And I'm excited kind of to see more and more of the now business use cases. Everything from financial, but also like your productivity tooling moving to that direction and really enabling it to the end user.
Yeah, I think it's interesting because this is also what we're trying to do with Urbit, right? Because the idea of a personal server goes back forever. It's at least as old as the internet, right? Because the idea originally was that the way you'd use the internet was from a personal server. Maybe you'd live in your house. The cloud didn't really exist back then. But in the 90s, people had some concept of like, all right, well, there's an email protocol, and it's peer-to-peer, and my computer will send a message to your computer, and that's how things will work. And then it turned out that it's really hard to run a personal server, and nobody wants to do it. And if you ask a sysadmin to run a personal server, he'll say, yeah, okay, pay me $150,000 a year and I'll do it. So the problem isn't that it's sort of technically utterly infeasible to do that. It's just practically infeasible because it's such a pain, because there's so much complexity, there's so many layers of software, and you have to understand so many concepts. This crypto is a very similar problem, where like, okay, well, there's this key, there's a bridge, there's this chain, there's this wallet, a lot of different new concepts for people, and even for technical people, like, I work in this field and I get confused sometimes. And so I think with Urbit, we're trying to make a personal server that's simple enough that normal people can just use it, and they don't have to understand all the technical stuff that I babble on about all the time, right? Like, they shouldn't have to know any of that. And so it's also a usability problem. Now, the Urbit thesis is that to fix the usability problem for personal servers, you have to go way down the stack. And so that's our approach. Is we rebuild everything from machine code, programming language, operating system, network protocol, applications, everything, right? But yeah, I do think that's we do need this personal server component, and we need blockchains, and we may need some other components too.
For sure, yeah. I mean, I think like decentralized storage, decentralized CDN, like we need few of these pieces, especially to build like high performance, video streaming and stuff like this. Like those are, still a little bit away. But I think like the interesting, like I'm really excited about having, Google Calendar and like project management tooling, and like with Urbit, like that's the first call we had. I'm like, Google Calendar.
That's right.
Let's replace that.
There is UCal.
Yeah.
Urbit
exactly.
project to build a calendar, and yeah, it should be better.
Yeah.
It should be better than Google Calendar eventually, right? Calendars, I think, are actually pretty difficult things to build well.
It is, but I think that's like calendars really, like, especially like for people, for like business people, is like that's where everything starts, right? And so like around that you can start building out all the other tooling.
Yeah.
But if we all locked into kind of using Google with that, it's like it continues being a challenge.
Yeah, I mean, you store your documents in Google Cloud. They might decide they don't like that document, and they might just delete it, or they might decide that they can make any decision they want. It's just not yours, right? So interestingly, I think that Near has some projects around this, and I think Urbit does too. Within Urbit, there's a company called Holium that's building a really like a desktop environment that they call Realm, and so the idea is you run it as an app on macOS, and but within that it feels sort of like a desktop or like a browser, but you have different workspaces, one for each Urbit group that you're in, and they have their own conception of what a group is. And then within each space, there's like an automatic shared audio call that everyone's in. You can collaborate on documents together. You can send chat messages. And the idea is that this is extensible, so anyone can just write a new app that uses this framework and uses the Urbit backend framework and the front end framework. And then when you write that app, then it has all these features that get plugged in. They also have a wallet and a browser and a bunch of other stuff. So Talon, also the oldest company involved in Urbit, they have their other group and chat suite, but that has blogging and forum type stuff built in. Also intended to be extensible with new sort of channel types. And what's interesting about both of these is that they're, you see the Web3 here with the permissionless extensibility, right? It's like there's nobody who gets to say whether or not that plugin is allowed to happen, right? Like Signal, the foundation, right? They want to have payments in Signal, but they ran into regulatory problems, is my understanding. So they have MobileCoin, they work with MobileCoin, but they can only do that in some countries, not in others. I don't even know, exactly the full story there, right? But this is a story that happens over and over again. If you have to ask somebody for permission to like make a plugin or make a different client for Twitter, a different client for Facebook, right? Then often you don't get that permission, and then everyone suffers.
Well, and remember that service also can just disappear. I think like one of the things that like a lot of people in Web3 use Notion, and Notion can just shut down, and like all of the content will go down. Like it's a startup.
Right. And then it's interesting because some of these startups or some of these companies are aware of this problem. Facebook, to their credit, lets you export all your data. Actually, one of my friends was just saying that it's 10 terabytes if you actually export it.
Well, mine was, I think, 10 gigabytes.
Okay.
I did it 5 years ago. I deleted my Facebook. I deleted. It's marked, it is deleted, right, in a database on Facebook.
Yeah, they flipped the bit, yeah. But but one thing that's interesting about it, and this is often how we pitch Urbit, is to say, like, okay, you can download this data from Facebook, right? So theoretically, you can exit Facebook to something else. But actually, if I download my data from Facebook and you download yours, we can't find each other. Like that social connection, that's really the value of having Facebook in the first place, is not reconstructible just from the data. And so this really goes to the point of it's not just data, like just data on its own is not really useful. You also have to have a program that knows how to operate on that data. Right, so with Urbit, in contrast, like if somebody shuts down a group that I'm in, I still have all the group data, including the members, the Urbit addresses of all the members who are in that group. And so I can just kind of reinflate that if I want, or anybody else can. And also the data's still there. But that social connection is still there. And this is also, if you're a publisher, you're publishing something on Substack or Patreon, something like that, that's your business, right? That's your livelihood, is like that email list. And Substack has done a good job with this, right? Where they actually let the authors keep their own email lists. And this is part of the reason that those authors like Substack so much, is because they know that Substack doesn't have that kind of kill switch on them. Yeah.
Yeah, I totally agree. And I mean, we've been working on more the public side of social, right? So we have Near Social, which is kind of a Twitter-like alternative where the graph, is on chain, and it allows user to kind of control it. And the benefit of that is more composability, where you can embed that graph into this wallet or that application into, your calendar, right? Can fetch that data and show you, if friends allowed to share their information. That allows to kind of have this connectivity and discoverability, but that's not, it's decentralized, it's stored on chain and controlled by you, not by anyone else. And so, and that's what I'm saying, the next step is adding private data that's stored on the user side, right, and enabling that kind of extension beyond that.
Yeah, and intuitively it seems like most of the private data, you really want to store that in your own Urbit, with some replications. replication.
Yeah, and so application, that's why you need application to render on the user side, so it can merge the public data from a blockchain and private data from Urbit server, from encrypted data stores, and really provide you the full behavior.
Yeah.
And that's where, to the partnership side, right? Like integrating kind of near like blockchain operating system gateways with Urbit is kind of this idea that we can actually start running this decentralized front ends directly on your Urbit that can compose all this data in one place, right? Kind of unite all those identities and being able to interact and also share with others.
Yeah, we'll see if I can describe BOS. Do you think it? Yeah, let's see if I can do it, and you can correct me. All right, so Near has this project called Blockchain Operating System, and what it allows you to do is it allows you to store code on chain. And this is pretty impractical to do on most chains, if I understand right.
I think it's impossible because the data limits on most blockchains you wouldn't be able to fit more than like 32 kilobytes or something. So like
I just wouldn't try personally. Yeah, but you can just do this on Near, and then the advantage of storing the code on chain is that you can store front end code on chain, right? So it's not just the code that's on the smart contracts that always lives on chain, no matter which chain you're talking about. But if you store the front end, that means that the code that actually runs in the user's browser, you can store that code on the chain, and that way this reduces the possibility for someone to censor that front end. And this actually happened with the Tornado Cash situation. I believe it was Uniswap, right? They had a front end that would not let you submit certain transactions. So the blockchain itself, uncensorable effectively, or at least at that layer. But the way that everybody was accessing that blockchain was through some website, and so the website decided to censor transactions. And for most people, there wasn't a good way around this. And so it's interesting, right? That like if you don't have this sort of censorship resistance at all the different layers of the stack, all the different like pieces of code that are running on everybody's computers, then at any one of those points that can be interdicted, and then you get censored, and this is what happens. So what you need is this like a full stack solution, like what you're developing, where there's code on the layer 1 blockchain, right? And then there's also, you need some sort of decentralized system to send that code down to browsers, because browsers generally can't access sort of blockchain nodes directly.
Not yet. They should.
Yeah. And well, how are you? We'll get to that in a second. Because that's interesting. But so at least for the moment, what you need is what BOS called gateways, where a gateway is just some server that reads the data off the chain. It will read this front end code off the chain. And so it'll read the front end code off the chain, and then it'll download it into your browser, and you run it there. And so that way, as long as you can find one of these gateways that's willing to send you this code down, somebody would have to censor all of those gateways in order to prevent you from getting it. And this is a very different situation from just having one website that everybody goes to.
Yeah, and importantly, it's all cryptographic, so you can verify that what you received is actually was published by, a Uniswap DAO, for example. Because right now, again, Uniswap.com is run by Uniswap Labs, which is not really Uniswap DAO, just a separate for-profit company, and they publish in front end, which may or may not be the one, they can get hacked, you don't know, right? So you don't have the provenance, you don't have the cryptographic proofs that this is actually, you interacting with the right thing.
Yeah, people call this software supply chain security, right? And it's just a huge problem throughout, not just crypto, but throughout the world, right? There have been all kinds of things where, somebody is putting together an application that they're sending down to users, and the way they put together that application is that they cobble together code from thousands of different sources. And then one of those sources gets hijacked, and they publish malicious code, and that malicious code makes it into the system, which then gets published down to everybody. So this is just a huge problem in general because software is so big, and so you have to bring together code from so many different sources in general. But yeah, I mean, it's a problem that you really see in crypto because this is that kind of software supply chain attack has also been used a number of times to just swindle people out of money directly. So you can really kind of see it.
Yeah, exactly. But then on the flip side, what we see as well is because this kind of changes the development paradigm, right? You're going from hey, I'm going to build a website, I'm going to control everything, and this is going to be my thing, right? Which is the normal world right now. And it very naturally fits with this idea of, and I'm going to take everybody's data, and you're going to be my user, and everything this. to really changing the paradigm and saying, actually, I'm just publishing software, right? Similarly, how you go to GitHub, you just publish software, somebody will use it, somebody will find it. And here saying, hey, here's a component, here's parts of the UI. Here is, some Uniswap. We keep using this example, but like, here's a swapping component, right?
Yeah.
And then somebody's like, oh, I really want to build a swap, but actually want a social swap. I want people chatting while they're actually doing this. So they take your component, they take the social part, they mix it together, they ship it. It took them about 2 minutes because you just wrote like a few lines of JSX, and boom, it's published. And now, you can embed that thing already directly on a social feed because again, everything is a component. You can embed them into each other.
Yeah.
And so now all your friends just seen it because you just posted it on your social feed. They start playing with it. They're like, oh, I like this. How is this implemented? They take a look at the source code, which is on blockchain. They're like, oh, this is really cool. You know what? I don't like swapping, this DeFi bullshit. Let me try actually to use social for my other application about, for example, writing documents for the communities, right? And so the idea here is like the discovery of things you can do. Remember back in when HTML was just starting, and everybody was just like right click and inspect code and like, oh, this is cool. I'll just copy some code and use it in my thing.
Yeah.
You get that effect, but with real rich UIs. And what in turn allows you to do really to build faster. We've seen people building 3 times faster than they normally would. Somebody just posted on Twitter hey, I done this quarter of my backlog in 10 hours, right?
Right.
And then somebody else hey, I just saw some really cool thing and asked my developer and he introduced it in 1 minute. Literally just ported that thing into his own UI, right? And so that kind of thing is starting to happen, but it fits into this idea that it's not your application that tries to gather all the stuff. It's actually applications belong to all the users and the users kind of, accessing it and plugging in data into specific application. And so that's a mindset change, right? Again, that fits really well with Urbit and kind of this open web philosophy that we're all trying to do. And
we talk about this a lot in Urbit.
Yeah.
And one of the things we talk about actually is that should be easier as a developer. It should be easier to build a decentralized application than a centralized one. For one thing, you don't have to do GDPR compliance and all this other stuff. You're not storing other people's data, which is generally something you have to be really careful about. But then also, you should get this composability where you can take one component, another component, stick them together, make a new program, which is, you'd think you'd be able to do this, and you can, but it normally takes a lot of money and time to do that in production, right? So to do that in a way where you're publishing an app and you're running a company and you want to actually integrate various services together and you want that to work for everybody and stay working, you have to pay to do that. It's each time you need to stick 2 things together, that's glue. You have to maintain the glue. You have to pay somebody to maintain the glue. And what that means is that you end up with just a lot less of it than there really should be.
Yeah, it's pretty much you publish code any gateway that now runs it, right? For whatever reason, right? Somebody runs it for profit. Somebody runs it on their Urbit. Somebody runs it on their desktop. Right now can access to this, and it renders on their side. You don't need to have the middleware. Right, there's still obviously validator nodes, etc., but then that gets handled now by the blockchain infrastructure. And so that kind of, as you said, really going away from hey, I don't need to handle any of the scaffolding, I don't need to handle any of the hosting, at least initially, unless you want to run your own gateway, and you can start really quickly, and you can leverage this idea that all those users now can have access to it, right? Instead of you publish it in your corner, you create a Twitter account and you scream into the void, you're now hey, all the users everywhere now have access to it easily. They logged in already, authorized, all of their data is already there. The kind of, the diff from going to imagine you go to a new social network and I don't know anyone, I need to log in, I need a new password, I need to figure out who this is, I need to figure out if they steal my data later. Here, somebody can launch new, social network on top of this existing social graph, publish it on the existing social feed, which, by the way, doesn't say hey, you cannot post about, any other alternative social networks. And then, people can start using it right away and already kind of logged in with all of their data, right? So there's just everything from development to getting initial usage and traction is so much more simplified because of this change of paradigm.
Yeah, and we see this in Urbit too. So one example is the app called Portal. There's a new Urbit app, and it integrates data from a bunch of your other apps. So there's an Urbit app called Pals that most people use. This is a very simple contacts app, but I'm just storing, a lot of other people's Urbit addresses, and I can tag them with how I know them and whatnot. But that's used for sort of gossip-like social discovery quite a bit in Urbit. And so Portal uses that to discover. So if I'm hosting a group, then my pals hear about that through Portal. So Portal is reading from the pals' data and from groups and collating that data and saying, okay, hey, this guy's publishing this group, he's hosting this group. This person's publishing this app, this person is publishing, here are these blog posts. So I just clicked a button and it linked all my blog posts. Right, and that's the kind of composability, like from a user perspective, that just feels really nice. And people often talk about WeChat being like this.
Yeah, so we kind of call it conceptually it's an open WeChat platform as well, because WeChat is almost an operating system in itself. It has media apps, it has finance, it has social, it has all of the interactions, identity there. And so we, in many ways going after it, but in an open way, in composable way, in kind of extensible way, and also in private way.
Yeah, that actually brings me back to the BOS, the blockchain operating system, and so what we're doing with Urbit right now is making it so that your Urbit can be your own gateway, right? So that basically all I need to access data from the near chain and front ends to use the near chain is just my own Urbit, which itself can talk directly to the chain. So I don't rely on anybody else. So there's just an Urbit app. I install it like any other Urbit app, and I click install, and then that can just pull down any front end data, like any front end code for any.
For anything. I mean, it's not just near applications. We already have Ethereum. We just announced ZK EVM partnership, but you can build Web 2 applications. People have built integrations with ChatGPT.
Really?
It's faster to build. It's faster to build. It's not like you need to build Web 3.
Well, it's almost like serverless, right? It's sort of like Amazon Lambda.
It's serverless, but like for front ends, right?
Yeah.
It's pretty much what smart contracts did for web services. We're doing that for front ends, right?
Yeah.
On that layer. There's a lot of middleware as well, just to mention, which need to power that, right? Because the data that you need to pull in from public chain not always organized in the exact way. So you need, ways to query it.
Yeah, so you have like a system of indexers that are listening to
you need decentralized indexers, which are protocols as well. You need, meta-transactions, so the users don't need to break their head figuring out how to pay for fees, right?
Yeah.
You need all these pieces really need to play together as one system.
Right.
But it's the same thing when you use your mobile phone. There's drivers, there is services, there is updaters, all of the stuff happening, and you just pulling in and clicking on your app and scrolling through a TikTok, right?
Yeah, you're looking at the tip of the iceberg, and there's this huge substructure underneath that. Yeah. One thing, to switch topics a little bit, one thing that I've been interested in for about 2 years now, at some point, somehow I just got thinking about a lot of Web 2 systems, and a lot of those big companies are something like a marketplace. So you have something like Uber, Airbnb, Amazon fulfillment and all the merchants, all that stuff. And you have Facebook Marketplace, Craigslist, and then even Google Search. You can kind of think of this way, where you have people publishing listings and then people going to the listings. So when I think about what are people using in Web 2, what's the kind of the modern internet stack? What are people interacting with? A lot of this has the same sort of shape. Right? And there are people publishing listings, there are people who want to access those listings, use them. And I think it's very interesting to think about what would it take to make those so that none of those are proprietary, centralized, closed source, Web 2 systems, and what would it take to turn those into Web 3? Right? So what does that look like? What technologies are required? Or do we need social, cultural changes to make that happen? Can we even make this happen? So I think that we can and we will, but I think that this is actually a minority opinion within Web3.
Yeah, so it is probably a minority opinion right now, but we were just talking about it before. So back in the day when Satoshi was writing Bitcoin code still, there is actually a file called market.h, which contains source code for a marketplace embedded directly in Bitcoin code. There was a way to list products, leave reviews, and do a few orders pretty much of products directly inside Bitcoin. So Satoshi originally wasn't just planning to build a financial system, financial payment system. He wanted to use it in actually buying real world stuff. And so
I didn't know that. I had no idea until you showed it to me.
Yeah, so I found out this like a few months ago, and because I was also thinking about exactly the same thing. I'm like, hey, especially when this like choke point thing in US started, and I'm like, hey, so imagine in US like it's probably like hundreds of billions of dollars in crypto people have, and let's say they shut down all of the like Coinbase and all the on-ramps, off-ramps.
Yeah.
So you have all these people with crypto not being able to spend it or withdraw it. Well, the thing that makes sense is to be able to buy stuff with crypto.
Be able to what?
To buy stuff. You should be able to go in the store and say, hey, I want to buy food for USDT or Bitcoin or whatever.
Yeah.
Right? And so that's where I started my research. I'm like, well, okay, how do we do that? And so there's few things that you need to do. Well, first of all, we need like software to do listings, etc. But this is actually the easiest part. Actually creating marketplace code and like doing that effectively. For example, on Near, very effective. 1 second finality, all easy. That's not where the hard part is. The hard part is actually in trust and safety.
Okay.
Because the second thing will happen after you launch it will be all the illegal stuff will get listed there.
Yeah.
And so then all the people will start going after it, trying to shut it down. This is where you need decentralized front ends, personalized servers to be able to access it, and pretty much being able to bypass a lot of the kind of choke points of the current infrastructure. And still, personally, I don't want to, show to everyone all the malicious stuff that people are trying to do, right? So we actually invest a lot in what we call trust and safety framework, which allows community governance, which allows communities to actually select what they don't think is safe, and you as a user can self-select into a community moderation. You can say
right. You want moderation, you just don't want it to be centralized moderation, right?
Exactly,
each community to do its own moderation,
And so ideally, you want you as individuals say, hey, I believe in this group, for example, in their ideals and their way of doing it, they're doing it transparently. When they are moderating something, they're actually leaving a comment, and they can be disputed. And so I'm going to self-select into the system, and now it just applies a filter on top of my view, so that I don't need to see all the disturbing stuff that humans have, right? And that's the reality. But the thing is, what disturbing is actually different from jurisdiction, from people, right? Like for example, in Amsterdam, all of the drugs are legal, and so the marketplace that in Amsterdam will be completely legal will be completely illegal in US, for example, right?
Yeah.
So having this applied filter is important, but it needs to be community driven, and it needs to be defined by the community itself and individuals opting it in. And if they don't believe in the government and in the laws of the countries they're living in, well, maybe they should change the country, but they can use, for example, Urbit server and choose a different alternative community moderation. And that's why gateways themselves can pretty much select which moderation system they use, and users can inspect that in a transparent way and understand how it works. So that is really important pieces. We need decentralized front ends, we need community moderation, we need search, which part of blockchain operating system as well. We need effective marketplaces, which one of the things we actually have is called Orderly, which is off-chain order book, on-chain settlement, which allows to have way more effective, for example.
That's interesting. Yeah,
transaction, and it settles every second. So it's actually better than centralized exchange end result, because you're on chain 1 second, and all the assets belong to you, right? It's self-custodial, but you get the performance and kind of execution speed of centralized exchange.
Yeah, that sounds like a good point in the trade-offs.
So all of these pieces need to come together, and now we can have a product, and then the actual hard part starts. Hard part is getting people out of Amazon.
Yeah.
Right? They need to have an incentive to now switch, because outside of buying stuff that is not on Amazon, which will be illegal stuff, there's right now not as much incentive to switch. So you need to find niches where there is important products that people want to buy peer-to-peer, or you need places where people are crypto rich pretty much and don't want to off-ramp and want to buy from somebody who's willing to accept crypto. So you need to find the niche products to start, and then as people gaining more kind of habit to using it, then you can scale into more generic stuff.
Yeah. So is the
so if somebody wants to build a startup, by the way, let me know.
So well, yeah. So what if you had to suddenly switch jobs and build a marketplace, what would you sell?
Well, so it really depends, but I think. I mean, the cool things you can start selling is like, for example, Urbit servers, right? Like people who want to buy with crypto, and you can, sell them Urbit servers directly and ship them.
Yeah, digital services in general seem a lot easier for this sort of thing.
There's server, but like you want to start finding what are the physical things that are hard to acquire right now and kind of deliver them. But like, and you want to see what are the people who have a lot of crypto are interested in. So you should go and do some research on that. And figure out what are those like, like I'm sure there is like some niche of things that are potentially it's like some services actually, maybe not the goods first, right? So that's kind of the maybe it's ticketing, maybe it's something else that like you need to find the kind of products that people are interested in buying with crypto.
Yeah. Well, we've only got a few minutes left. One thing that you had mentioned to me is that you said you wanted to have a Bitcoin VM in Near. Can you describe what you mean by this?
Sorry?
You had said that you want to have a Bitcoin VM in Near. Can you describe what you mean by this?
Yeah. So Near allows to run other blockchains on top of it. So
other blockchains, what?
On top of it.
Okay.
So we have a project called Aurora, which is an EVM, Ethereum virtual machine, running as a smart contract. So you can run a whole other blockchain as a smart contract on there. That's kind of how powerful, that's why you can store source code, right? You can do whatever you want. Like, the limits are, there are limits, but they're not that big, and we're trying to push them every time. And so one of the cool ideas is actually you can, instead of creating another fork of Bitcoin, trying to, make blocks bigger or whatever, you can actually port Bitcoin VM on top of Near, port the state as well, and now you can have, it's a fork of Bitcoin, but it runs on Near infrastructure. You can have better transactions, so you can pay pretty much transaction fees in this fork Bitcoin, and you can burn part of it. So you can actually start having a deflationary Bitcoin fork with way larger blocks and with the same state. So that's just like an example of something you can build on there.
Yeah, I would call that a Galaxy brand idea.
So again, inviting someone, if somebody wants to build a cool project, let me know.
Yeah.
I have a list somewhere of all of this crazy ideas, yeah.
Yeah, I have a few lists of crazy ideas for Urbit too. I think it's important to maintain the crazy ideas. At least for me, when I'm involved in Urbit, most of my work is day to day reviewing code, looking at pull requests. And I think it's good to have a big picture of where we're going.
Totally agree. Yeah, that's why I like to remind hey, we're here to give all people control over their assets, data, power of governance. Okay, what does this mean, right? Assets, we're kind of getting there, but still not there. Data, well, we need things like Urbit. We need more on-edge compute. We need a lot more things. Governance, we actually have Near Digital Collective. We're trying to innovate and pioneer and try to figure out things. Now we need to make all of those things work together, right? Marketplaces is actually data and assets together, right? Yeah. And you need governance for trust and safety, right? So you need to start making this connections, because right now, hey, you have assets, but then no governance. It's going crazy. People getting hacked. How do we fix that, right? So I think continue looking at vision, but then bring it down to what are the things that are broken, and how can we bring some of these pieces together and address it?
Yeah, well, we're here for it. Thank you very much for coming.
Thanks for inviting me here. It's great to be here, and I'm excited to have more and more kind of integrations between Urbit and Near.
Me too. Thank you.